infrastructure with cloud architectures, also we start getting more possibilities where we configure things. So, for example, in a Kubernetes setup, you could also introduce sidecars with service meshes. And having a service mesh for me is quite interesting because it adds possibility to configure features at different levels of your architecture, actually. And I talked about the communication over network. And one thing that we know basically is that the network is not the most reliable thing all the time. So having a retry for services is quite handy. And now with the possibility of having a service mesh and code, you have two possibilities to configure retry. In the corner on the top, you see you can basically do it in your code. So you could basically implement a retry mechanism in your code. But also a service mesh can provide you here in the YAML file a possibility to configure the retry. So architecture in general becomes a little bit more complex, not maybe on the service level, but in general on the total level. And also the complexity adds more possibilities. So having the general overview helps you at least to understand where certain things are happening. And the second thing actually is, let's talk about requirements. We talked about how our software architecture looks like and what observability needs to observe there. But we also have we have different requirements. And also on the observability lens, we can look on the requirements that we have. And one thing you often hear, if we talk about infrastructure, if we talk about DevOps, is actually reliability. And with reliability, I would say it's not one shirt fits it all. It's different. It depends on your product. So always consider reliability from the perspective of the end user. So, for example, if I open my application for booking a co-working space on Monday on a Saturday evening, and I get back the error message that the server is not available. I mean, I would be a little bit disappointed, but I can think, oh, I do that on Sunday then. I book my space on Monday. So my experience as an end user is not great, but I'm not super affected. On the other hand, if I then open my messenger app, Signal, and I want to message my friends and say, hey, let's go out tonight, and I get the message, sorry, it's unavailable at the moment, my user experience is a different one. So reliability relates for different products and for different systems into different things we need to consider. And then also it needs to different things to consider that we want to observe. And when it comes to that, basically, obviously, and I think that's something we sometimes do too late, we think of what makes our system reliable. So we think of the service and the feature that we offer for the end user. But then also we need to think, how can we measure that in the end? Because the end user experience might not be the best thing to measure. But based on that, you can basically create metrics from your systems and think of SLOs based on these metrics you want to create. For example, if you know there is a certain call that a user can make in your application, you might want to you might consider how many times do I get an error back on this call, and if I have a certain threshold, this is actually a problem, and then we need to think of redesigning maybe parts and things of the system. And yesterday there was a really good talk about measuring reliability in production and the whole art itself of how to create those SLOs and how to actually build them up. But I think it's good to have that already in the phase when you talk about software design, also have the part of observability to really ensure how can we measure in the end that we are reliable with our software. And that's the second part. And the third part actually is, if you think of building an architecture about evolution instead of piggyback architecture. I found that in an article, and I really like the idea that you want to have an architecture that you build that is flexible for change and that you don't want always to add on top, because that makes your architecture heavy and more complex in the end because you add more components. So if you could reduce it and change things by evolution instead of putting on top, you are more ahead and you can reduce some complexity, makes it easier for you to understand the system. And I mean, we had this picture already, and I feel that's already quite complex if we consider our system that runs on different layers with different components. And now often what you would see is when observability was maybe not part of the design process in the first place, but now someone says, oh, we should observe this, then often the solution is, okay, let's buy this observability suite, and we can put it on top. Maybe it doesn't run in our network, maybe it runs somewhere else, but yeah, we have something we can observe. And of course, you get something probably quite quick out of the box, but you also have a high dependency on this observability suite because you want to make the system observable. It becomes a requirement now. And you are kind of dependent on prices and on the vendor, and you cannot have that many configuration or possibilities to configure this. And now that's where the currywurst comes basically in. If you consider this solution as the currywurst you can maybe buy in the supermarket, that's the one that I can easily prepare. I can put it in the microwave. It's easy for me to cook, but my configuration possibilities are a little bit limited. What I can do here is to change it. I can add on top. I can add salt and pepper, but I don't really have the possibility to take components out if I don't like them. I have to deal with what I have. Obviously, there are not just only vendors in the supermarket. There are in Berlin a lot of nice food trucks where you can get really good currywurst. And you can see here you have more configuration possibilities because you can talk to the vendor, and the vendor allows you probably to take certain things out, but you are still very dependent on the vendor and the decision what the vendor is offering. If you want to do it differently, there's the last option that you can do if you want to eat a currywurst in Berlin. The different vendors, so vendor doesn't equal vendor, but there's the last option. I can go and cook it myself. I can use all the components that I know, or that I might know or want to get to know, and try to make my own sauce. And this has the benefit that I'm really in charge of what I want to include. But obviously, maybe you can imagine if I do it for the first time, it will not be the best currywurst. It needs some expertise and some knowledge to deal with those things and to cook it up. And if we look into the observability space, what we have here basically on the application level, just per se, is that these are the components that we need to consider. So we have the application. We need something to instrument that application to get the data out, like the traces, logs, and metrics. And then we need to store them in different observability backends, basically. It's depending a little bit what solution you use, but you might have different solutions for metrics, traces, and logs. And then based on that, because you don't want to look into those tools independently, but you want a unified way of having dashboards and maybe also alerting, you need to put something on top so you can basically see what you have. And putting some names behind those tools. We have tools here in the open source space that allow us to do that. So it's quite possible, and it was possible before, to build an observability stack based on those tools, like putting them here. We have Jaeger and Zipkin for the traces. We could use Prometheus and Grafana for metrics, and Logstash and Grafana Loki for logs, and there might be even more around that you could use here on the open source side. And then there is a possibility with Grafana and Kibana to create also this kind of visualization platform. What has changed in the space a little bit is that before, I would say the preface was that a lot of vendors, proprietary, but also like open source vendors, they all provided own clients to instrument basically your code, your functions to get the telemetry data out. And now with OpenTelemetry on the horizon, we have actually a project that is really tackling this phase of the observability stack. It's about the instrument generating and collecting and exporting this data to get it out in a very vendor neutral way. So that means basically once I instrumented this, I can exchange my backends as I like, as long as they are compliant with OpenTelemetry. And OpenTelemetry provides us here some SDKs to instrument our code manually, but also some specifications and semantic conventions, how things should be named to make it, to unify that, to make it possible for vendors or for us to exchange our backends. And what is really good here is that it's not just open source tools being committed to the standard, but also we see different vendors that are committed to the standard and provide knowledge in the creation. And I think if you want to get started today with OpenTelemetry or with something, what I would recommend is look into the auto instrumentation they provide for different applications, because they are quite good, and see if you can hook them up with something you have in your observability stack already and see what you get. Because those auto instrumentation clients give you already a lot, and then from there you can start thinking of the configuration. We at Fiberplane, we also have a product that we are cooking up, I would say, at the moment with all those different components, and that's why I think it's interesting. We also try to instrument application code. Basically, we are more opinionated about it, so we instrument the functions, and we write the PromQL queries already for you, so you get out of the box the latency, error, and request rate, and then obviously you can hook it up with Grafana or with any other tool for the visualization. What I think is quite interesting here is flexible, so people can still choose own ingredients, but also like see how we can help to make observability a little bit more out of the box without providing a whole suite already. Yeah, and that brings me basically already to the end. So when architecting an observability stack, I think there are those three components that are important. It's the complexity of the system we should consider, and also the complexity if we add observability on our own, that should be considered in our design phase. We should look at the requirements and maybe also make sure that in our design phase we have observability already as a requirement defined. And in the last step, also think about the evolution, how you can be sure that you don't start creating a heavy-weighted architecture in observability, but be in charge of your own, of your own stack. And that brings me to the end. Thank you.